Alright, so this is part 2. We're going to continue on with the area of rectangles and parallelograms. And we're going to start with an interesting problem of a square within a square. So let's say we have an outer square and we have an inner square, but we only want to know the area of the outer square. And not the area of the outer square, I'm sorry. We only want to know the area of the shaded part between the two squares. Let's imagine this whole part is shaded in, and we want to know the area of this yellow part. Okay? That's what we want to know. Alright, so how do we figure that out? Alright, what do you think we should do? Let's say this side is 9, and this side is 9. That's the outer square. And then with the inside square, the base of the inside square is 3, or a rectangle rather, and the height is 2. So how can we figure out what the yellow part is? Well, first thing we can do is we can find out what the area of the entire big square is, which is going to be area equals 9 times 9, which is 81 units squared. Now we know the whole area of the whole figure. Now, what is the area of the smaller square? So area of the smaller rectangle is going to be 3 times 2, and that, of course, is 6 units squared. Now, to find the area of just the yellow region, we have to take the little square area, take this area away from the big square. It's like taking a bite out of a big square donut. We have to take this away. This part has to be taken away from the larger square. So we're going to subtract 6 from 81, and we're going to end up with 75 units squared. And that's the answer for the area of the yellow shaded region on this problem. Okay, now we're going to move on to a parallelogram. Okay, now parallelograms are the same formula. Area equals base times height. Okay, same formula. But the interesting thing about parallelograms is the height is actually not part of the figure. It's on the inside of the figure, or sometimes they write it on the outside. Like this could also be the height out here, but we're going to talk about it on the inside. This is the height. This here is just the side, so don't get confused. This here, of course, is the base, and this is the height. Okay? So in this parallelogram, let's say the bottom is 6, let's say the side is 5, and the height is 4. Alright? Now to find the area of this parallelogram, the area equals the base, which is 6, okay, times the height, right here, which is 4, and that's going to be 24 units squared. Now, why do I care if all I need is the base and the height? Why do I even care what the side is equal to? Why do I even care the side is 5? That comes into play when you're looking for perimeter. Now remember, perimeter is the distance around the outside of the figure, as if you were walking around the outside of the figure, like a track. So that's going to be 6 plus 5 plus 6 plus 5, which is 22 units. Okay, and that's it. 6 plus 5 plus 6 plus 5, 22 units. And that's the perimeter. And that's how you do area and perimeters of parallelograms.